We'll proceed in pseudo multivariable calculus. Pseudo multivariable calculus, that is something, the discussion that we have started. Pseudo multivariable calculus. Okay, what is pseudo multivariable calculus is, can we write a mathematical equation? Can we write a mathematical equation with with simple addition, subtraction, multiplication, and division, and later we will come to a conclusion that we can use calculus, but it will be a smooth transition from the normal mathematical equation to the calculus equation. Now in calculus equation, it can be a single variable, it can be multiple variable. Multiple variable means multiple independent variable. Single variable means single independent variable. Okay, multivariable calculus is considered as something that is above the head of many one. What is multivariable calculus? Okay, anyway, pseudo multivariable calculus. And we have started an initiative that, okay, anyway, what is the idea behind mathematics and calculus is that if we are writing mathematical equation and wherever we are seeing multiplication of two items and one item is a function over another item, like x square into x, where x square is dependent upon x. Certainly it is dependent upon x because it is x square, square of x. Or I have multiplication of two items, that is called y into x, and y is dependent upon x, y equal to x square. In that sense, we can write it as y dx. If I have z, z, z into xy, where z is a function over x and y, then it will become z d of xy, that is xy plane. If we multiply two items and one item is dependent upon another, z is dependent upon xy plane, where xy plane has two independent components, x-axis and y-axis. This is how we break it. Anyway, but still, the multivariable calculus is above the head of many calculus maestro. Anyway, in that sense, we have brought the concept of length vector. The concept called length vector. Length vector in the sense that if I have a line, if I have a curved line, that curved line can be represented through a vector. If there is a curved line can be represented through a vector in a way that there are two ways. One, we have, if this is x-axis, if this is x-axis, this is x-axis, then consider this is x-axis and this is the line above the x-axis. This is a curve. If this is a curve, then any point if I take, what is the vector representation of this curve? That is a question. What is the length vector? Length vector means a vector that represents this curve. Okay, there are two things that we are talking now. One thing is that how I can find length. This is x-axis. Okay, this is x-axis and this is a line. What is the length of this line from point origin and point x comma y? To, so that I can represent, consider that I am calculating the force into length as energy, whereas this is x-axis, this is x-axis, this is a displacement line along which item is moving, and this is a force field. Against this force field, item moved from here to here along this line, from origin to point x comma y. How much is the energy that is released by the energy source through which this is the force field? That energy is force field dot product with the displacement vector, or from origin to x comma y. If item is moved because of this force field, how much is the energy involved? Force vector dot displacement vector. Now, what is the displacement vector for this? If this is origin, this is x comma y. I'm sorry. The net energy is force magnitude into displacement into cos theta. That is the most basic mathematics. What is the work done by the force? Then what is your force magnitude? How much length it moves into cos theta? That is also, now what is the length? This is the core mathematics. What is the energy involved is force magnitude. Wherever direction it is going, doesn't matter. Force magnitude into displacement, it makes the item move. Force magnitude into displacement magnitude into force and displacement angle cos theta. That is the net energy released by the energy source which is making the force field. Okay, in that sense, force field. Now, if someone go in a vector notation, then it is force field, capital F, force field, on top of it arrow mark, force field, on top of it arrow mark, dot product dot product with the displacement vector, or force magnitude displacement magnitude cos theta. So this is, now if I go with the calculus fundamental, then force vector. What is the representation of force vector in calculus? What is representation of displacement vector or length vector in calculus? Dot product. Why we want calculus formation? Because not necessarily the displacement will be a straight line. If this is a force vector, not necessarily force vector will be straight line. In that sense, we need a vector representation of a line. Line can be, if this is a force, because of this force, one item moved from origin to point X in this direction. We have given example for it. Like if I have a if I had a lock, where it went, that I don't know. Okay, if it goes, okay, nice, thank you. So the idea is that this is a force field, and there is an item like this, and this item started moving because of the force field. But it is pierced into this path, and it will move only along this path. Okay, in that sense, what is the energy calculation? Force field dot displacement vector. Slowly, we started with the force magnitude, displacement magnitude, cos theta. Then force vector dot displacement vector. Now, both are a straight line. Now, consider force vector is a straight line, but displacement vector is a curve. Now, how I can represent the displacement vector as a simple vector? If I take the item is moving in a curve point origin to point x comma y, if I represent it through vector, then it will be xi plus yj. That is not the concept, because it is moving along a curve, not in a straight line from origin to point x comma y, so that I can take it as xi plus yj. We started a discussion that how we can find a distance from origin to a point x comma y along a line that is y equal to some x, sin x, x square, 4x, or something like that. Okay, in that sense, the idea was to represent this line. The idea was to represent this line as a vector and then calculate the magnitude of the vector. Then you get the distance from origin to x comma y. Okay, in that sense, it led to a new terminology called length vector. A new terminology called length vector that came into picture after this. What is length vector is what is the representation of a vector that connects a point origin and point x comma y, that is xi plus yj, that is same as I plus y by x j bracket closed into x, that is same as I plus dy by dx j bracket closed into dx. Division become differentiation and multiplication become integration. This is called length vector. Length vector, that is along a line. If it is a curved line, also our length vector I plus dy by dx j bracket closed into dx works for the curved line also. This is called length vector. Mind blowing, amazing. This is called length vector, that is I plus dy by dx j into dx, or xyy dx by dy I plus j into dy. Same thing. Either I take x out from xi plus yj, or I take y out from xi plus yj. And then division becomes differentiation and multiplication becomes integration. So integration is multiplication and differentiation is division only by its heart, by its core of the bottom of the heart. It is like that. Now, in that sense, now we verified that actually the we are keep on talking about our length vector is I plus dy by dx j bracket close into dx is indeed it is a length vector. It is along the length, it along the line this vector is. If I calculate the magnitude of this I plus dy by dx j into dx, it will give the length of the vector because we are calling it is length vector. It started from the fundamental that any line that is passing 0 comma 0 x comma y, the length of this line section can be represented through the magnitude of a vector that represents this line, that is xi plus yj. If I calculate the magnitude of this xi plus yj vector, indeed it is the distance from origin to x comma y. Xi plus yj, it should represent the straight line vector also or curve line vector also. In that sense, we saw, please watch our previous video, we saw that we have to represent this xi plus yj in term of y by x. That is required because y by x for the curve line is different at different moment, so that is required. We took out x from it and it became I plus y by xj into x. Later it became I plus dy by dxj into dx. Okay, that is the science called length vector. Anyway, there are other philosophy for the vector, line vector. There is one called length vector. We are saying I plus dy by dxj into dx is length vector because if I calculate the magnitude of this, then it gives the length of a curve line. Otherwise, it will represent the curve line. Make sense? There is another thing called line vector. There is another thing called position vector. If I have a curve line and this is origin and this point is x comma y, if I take a straight line from origin to x comma y, this is called position vector. If I differentiate this position vector at x comma y, then it will become a tangent vector at that point. This is known to everyone. If I have a position vector and this position vector is xi plus yj, if I calculate the derivative of xi plus yj at this point x comma y, it will result into new vector. The derivative of xi plus yj will result into new vector and that vector will be tangent at point x comma y. Okay, everywhere. That is called line vector. So derivative of xi plus yj is also called line vector. Dxi plus dyj is also called line vector. And our length vector, that is I plus dy by dxj into dx, it will also break into dxi plus dyj. I believe if someone breaks it. So I have line vector in two fundamental. One is I plus dy by dxj bracket close into dx. Another is dx by dyi plus j into dy. Whatever someone can use because the base is xi plus yj. Xi plus yj we transformed into taking x out then I plus y by xj or y out then x by I plus j. Anyway, that is the concept. Now we are behind the fundamental that our length vector, that is I plus dy by dxj bracket close into dx, indeed it works with the path independent force field. What is path independent force field? Path independent force field is a force field where energy calculation is only dependent upon the begin point and end point and the force, not on the path. Like Earth gravitational pull, that is xi plus yj plus zk divided by x square plus y square plus z square to the power 3 by 2 is path independent. If Earth, if there is, I'm showing the Earth, I have real Earth. Okay, so consider that I have an Earth. Okay, I really have an Earth. If this is the Earth, What is it very heavy? If this is the earth, then what is the gravitational pull of this earth? If this is the earth, then what is gravitational pull of this earth? This is the gravitational pull of the earth all along. This is called radial gravitational pull. Okay, that is described as minus gmm r vector divided by r to the power 3. Minus because it is going coming toward the center of the sphere. G capital G is the gravitational constant. One m is mass of the earth and another is the mass that is getting attracted toward the earth. That this is, and then r vector divided by r to the power 3. If I take out the constant, then r vector is xi plus yj plus zk divided by x square plus y square plus z square to the power 3 by 2. Anyway, that is the scenario. This force field is called path independent. Path independent means if something is going towards earth, then earth is working on it. That's why it is moving. If something is moving towards earth, means if there is a mass and there is a movement, then there is energy involved as per Sir Einstein. If a mass is moving with velocity v, then energy involved in the moving the mass with velocity v is mv square. That much energy is involved. If there is a force field, consider there is a magnet. One magnet is kept, that because of the magnet all around magnetic force will be there. One iron come in the vicinity of the magnetic force field, and iron is moving toward the magnet. Okay, in that sense, who is losing the energy? Because iron was kept still. Okay, anyone can try. Keep a big magnet on the table and then keep one maybe iron particle that will be very lightweight, iron particle somewhere, and start pushing towards the magnet. One point will come when magnet will attract it. Okay, all of a sudden, how come velocity came in the mass? If velocity is coming in the mass, then energy involved. Iron does not have any energy in that sense. Then who is losing the energy? Then magnet is losing the energy. If you take a big iron and let it move toward the magnet and then again distract it, or let it go toward the magnet, then take another iron, let it again go toward the magnet. Keep doing with the new iron ball. After some time, magnetic field will go away because it has lost all the energy making the iron move. So, in that sense, if any particle is moving toward Earth, then Earth force is coming into the picture. Or because of the Earth force, item is moving toward the Earth. How much is the work done? Means how much energy Earth is losing. If this is down, if my down is Earth, if I lose this, then this item falls like this. Earth started working. If this point is A and this point is B, then the energy that is lost by the Earth is dependent upon point A and point B and force, the force that is available at that point, because force is decreasing if we go away from the Earth. If I go 100 kilometers away from the Earth magnetic force will be very less. At the sea level, it will be maximum as far as the it loses the force is inversely proportional to r square or directly proportional to 1 by r square. The way we go away, force decreases. In that sense, this is how, so making an item move from 100 kilometer from the surface of the earth 100 kilometer away to 99 kilometer away, 1 kilometer movement, and making item move from 1 kilometer from the surface touching the surface, energy lost by the earth is different. Here, energy lost by the earth is more if it is near to the earth, whatever it is. Any moment, what is the earth gravitational force into begin point and end point? That only matters, not the path it is taking. So if someone is dropping the ball from the 10-story building to the ground, the earth is losing energy and he is going to 10-story building staircase and then he is leaving the ball. Through staircase, ball is coming to the ground. Earth is losing energy again. But in that sense, the energy lost by Earth will be same if begin point and end point are same. This is called path independent. Means Earth gravitational force is gravitational force into distance is the net energy lost by the earth, and that distance is begin point and end point connecting a straight line or whatever it is, not on the path. This is called path independence of any force field. If force field is path independent, the energy source through which this force field is maintained, energy source will lose energy that is dependent upon the begin point and end point of the mass movement, not on the direction that it is taking. It may take infinite direction to satisfy the begin connecting the begin point and end point. Okay, now idea is we have invented a length vector. Wherever we need in mathematics, that is something called length. Length, because energy calculation was force magnitude into length magnitude into cos theta. Okay, in that sense, people would say this length magnitude I can wherever length comes, I can just put in our length vector. So length vector magnitude is length vector is I plus dy by dx j bracket close into dx. Now this length vector magnitude if I talk, then it becomes 1 square plus dy by dx whole square, a square root into dx dx from begin point to end point. If someone calculate it, where what is dy by dx? Y is the equation of the line that connects the begin point and end point. That is dy by that is y. If it is if if the item is moving, if item is moving, if the force into displacement, force magnitude into displacement magnitude into cos theta. If displacement is happening through a curve line, if displacement is happening through curve line, then this displacement length, okay, this displacement length, if displacement is happening, this length is y is x square. This is what I am taking. If displacement is happening through a straight line, then the displacement line is y equal to x, y equal to 4x, whatever it is. There we have to calculate dy by dx. In that sense, wherever I see length vector, I can directly substitute here I plus dy by dx j bracket close into dx, or dx by dy I plus j bracket close into dy. If I see length magnitude, then I can say 1 square plus dy by dx whole square root into dx from begin point to end point. This is our invention called length vector. Anyway, the idea is if I know force vector field as path independent, our length vector works out there. Now, in order to go with that, we will consider this. We will go with the multivariable case where x and y is there, or whatever it is. We will In the past two video sessions, we are talking about calculation of the potential energy function. How to calculate the energy with a force field that is capital F. Capital F is a what is energy calculation in terms of vector? Energy calculation in terms of vector is force field dot product with the length vector is the energy vector. Force field dot product with the length vector. Force field vector dot product with the length vector is the net energy calculation. Force field force field is F1i plus F2j if I take only xy plane. Dot product with the length vector, that is I plus dy by dxj into dx, that is our length vector. That if I go with this multiplication, it will become dxi plus dyj. Now, idea is dxi plus dyj will be different for different y and x relationship. If path is y equal to sin x, then I plus dy by dx will be different for sin x, dy by dx different for y equal to x square, depending upon the path. If I take, now idea is let's go with the generic path in terms of proving that our length vector indeed works with the path independent concept. If I go with the path independent concept where we are worrying about only begin point and end point, then it will take all possible paths. For one particular path, we have y equal to x square relationship. For another particular path, connect same 2 points. I have another particular path, I have relationship with y equal to 4x. Now connecting these 2 points, I have another path where I have one vertical line and I have horizontal line. or I have a horizontal line and I have a vertical line. There can be innumerous paths connecting two points. In that sense, I have innumerous y and x relationship. Let's go with a generic method where I'm not going to break y into x. This is what we keep on telling. Don't break y into x. Don't break y into x, and let's go with a generic length vector, that is I plus dy by dxj into dx, or dxi plus dyj. Now go with the dot product with the force vector. Force vector is f1i plus f2j, dot product dxi plus dyj. Now in a generic term where we are not breaking y into x, this is called generic energy calculation. Generic energy calculation is F1 dx plus F2 dy with the dot product. What is F1 dx and F2 dy? Consider F1 dx and F2 dy. It resolves into a generic algebraic equation called gxy. Makes sense? Consider force vector field is xi plus yj. In that sense, x dx plus y dy, at the beginning it looks like I can do direct integration, that is x square by 2 plus y square by 2. In that sense, we receive this integration as gxy, that is x square by 2 plus y square by 2. Okay, now if I have gxy, if I have any function called gx, consider I have any function called gx, then gx is same as integration of differentiation of gx. Make sense? That is dgx by dx into dx, dgx by dx into dx, integration is gx. Gx is same as integration of derivative of gx. Similarly, if I have f1 dx plus f2 dy, that is the net energy calculation for a generic path where I am not breaking y, then it will resolve into an algebraic function gxy. Gxy is same as integration of d of gxy. What is differentiation of gxy? D of gxy is same as d of gxy by dxy into dxy. That is derivative of gxy with the xy plane into d of xy. Now derivative of gxy, that is multivariable function g and bracket x comma y, multivariable function gxy, it will resolve into a vector that is also called partial derivative gradient vector, that will come as dgxy by dxi plus dgxy by dyj, and then we have d of xy plane. Now, now this, if this is a vector, then d of xy plane cannot be a d of xy. It will has to be in a vector. Then it will become d of xi plus yj. When two vectors are there, they cannot multiply simply. We place there a dot product. Anyway, so the f1 dx plus f2 dy, it came as gxy. Gxy is same as gxy from A to B, because our net energy calculation from force vector dot dxi plus dyj from point A to B become gxy from A to B. It is same as integration of A to B dgxy by dxi plus dgxy by dyj, dot product dxi plus dyj. This is not this explanation is not available in any of the big book when we are proceeding from the path, and we are not considering it as path independent. Rather, we are considering it as all possible path. That's why we are not breaking y. If I break y, then everything will go away. Now, in that sense, the whatever we are getting now from the A to B, dgxy by dxi plus dgxy by dyj, dot product dxi plus dyj, it is same as what we saw in the energy calculation, integration from A to B d, so I'm sorry, f1 dx plus f2 dy. Okay, here it is dgx by dx into dx plus dgx by dy into dy. Looks like f1 equal to dgx by dx and f2 equal to dgx by dy. If this things are harmonious relationship. It is coming only when we have taken independent path or generic path. If I take generic path and if I go with this kind of scenario, then we come with a relationship that f1 equal to d gxy by dx and f2 equal to d gxy by dy. Okay, how to get gxy in that fashion? That is a question here. Now, but with the path independent fashion, we have got a relationship through generic path that f1 equal to d gxy by dx and f2 equal to d gxy by dy, where gxy is the algebraic multivariable function we have received from the integration of f1i plus f2j dot d of xi plus yj. There we have received. Now, this is called path independence theoretical relationship, that f1 equal to d gxy by dx and f2 equal to d gxy by dy. But how we receive d, how we get gxy from the f1 dx plus f2 dy or f1i plus f2j dot product d of xi plus yj? How we get this? Now, to answer this question, how we get this, consider our force field is xi plus yj. The net work done is f1 dx plus f2 dy. Can we get gxy directly with this? That is x dx plus y dy, that will come as x squared by 2 plus y squared by 2. This is not the correct path. If this is correct path, then d gx by dx should be f1 and d gx by dy should be f2. Their multivariable calculus hit in. Now, someone would say, my force field is xi plus yj. Now, if I do f1 dx plus f2 dy as energy calculation, then it becomes an x dx plus y dy. That comes at x square by 2 plus y square by 2, that is gxy. If I differentiate gxy with the dx, then it becomes x. If I differentiate with the y, then it becomes y. This is what we have force field as xi plus yj. So this is this way of calculating gxy from f dx, f1 dx and f2 dy looks like correct, not necessary. Let's try again. Consider the force vector field is y cos xi plus sin xj. This is what we are doing. Y cos xi plus sin xj. Now, as per our fundamental, y cos xi dx and sin x dy will give the gxy. How to calculate gxy? That is the concept. Theoretically, we did everything. Now, y cos xi dx becomes y sin x. Y cos xi dx gives y sin x plus sin x dx, sin x dy gives y sin x. Here also y sin x, here also y sin x. f1 dx plus f2 dy gives gxy. Now, in that sense, we have y sin x, where f1 is y cos x. Mind it, our force field I have taken as y cos xi plus sin xj or y plus sin xj. I'm sorry, just keep it sin xj. Sin xj. Okay, if I just keep it sin xj, y cos xi plus sin xj. Now, if I calculate f1 dx plus f2 dy as gxy, then it becomes y sin x plus y sin x, 2 sin x. If I do d gx by dx, then it becomes 2y cos x. But I have f1 as y cos x, not 2y cos x. D gxy by dy, that becomes 2 sin x, but it is only sin x. This proves that this is not the correct way to calculate the gxy. I know that if I get gxy, that is a kind of generic, then gxy is same as d gxy by dxi plus d gxy by dyj dot product of d of xi plus yj. That's why f1 equal to d gxy by dx and f2 equal to d dx by dy. And it is path independent because we took y, we did not break the y, we took a generic path. But this is not the correct way to get the gxy. That is f1 dx plus f2 dy is gxy. This is not the correct way. Or I can try force field is y cos xi plus y plus sin xj. In that sense, f1 dx that becomes y sin x. f2 dy, f2 dy, f2 is y plus sin x, f2 dy becomes y square by 2 plus sin x y. Now altogether it becomes 2y sin x plus y square by 2. Okay, if I calculate dgx by dx, then it becomes 2y cos x, whereas I have f1 as y cos x. Dgx by dy, then it becomes 2 sin x, 2 sin x plus y plus 2 sin x plus y, whereas our f2 is y plus sin x, not y plus 2 sin x. It is different. This is not the correct way to get the gxy when we are going through the generic way. Then what is the correct way? Correct way is that since we know that f1 is dgxy by dx and f2 is dgxy by dy, let's calculate gx equal to f1 dx, gxy equal to f1 dx and gxy equal to f2 dy through that concept that we have seen in the past video. So if our f1 is y cos x plus y cos x I plus sin x j, then gx equal to f1 dx plus some constant. I believe it is alright. So that dgx by dx equal to f1 and some constant will go away, or that constant can be a function over y only. Then dgx by dx, y will go away. I'll repeat it. Dgx by dx equal to f1. In that sense, gxy equal to f1 dx integration plus any function over y. So that dgx by dx will become f1 plus 0. Same. Now in that sense, we have f1 as y cos x dx integration become y sin x plus any function over y. Now, if this is gxy, if I differentiate this gxy with dy, it should become f2. In that sense, y, in that sense, y, I'm sorry, differentiation of y sin x plus any function of y with the y, differentiation with the y should become f2. That is just sin x. Now it becomes sin x plus derivative of any function over y, any function of y becomes sin x gone. Derivative of any function over y is 0. So function over y is 0. In that sense, gxy is y sin x. This is the correct way to calculate the gxy. If I use that's why multivariate calculus is little tricky. In that way, we have got the way to calculate gxy. Now we had taken y, did not break the y, and we took the generic path. Then through generic path, we are able to calculate gxy, which fulfills dgxy by dx is f1 and dgxy by dy as y. In reverse fashion, antiderivative of gxy also works. Let's take another example where force field is y cos xi plus cos xj. Force field y cos xi plus cos xj. In that sense, gxy equal to integration of y cos x plus c, any function c over y. That is y sin x plus any function over y, that is cy. If I differentiate it with y, then I should get cos x. That is the jth term. If I differentiate with the y, it becomes sin x plus derivative of c function, that is function of y1 equal to cos x. Okay, in that sense, derivative of cy becomes cos x minus sin x. Then integration of cos x minus sin x with dy becomes y sin x minus cos x. That is a function over y only, but it has x also. The whatever we are, I will repeat it. The idea is dgx by dx equal to f1. dgxy by dy should be f2. Now gxy equal to integration of f1 dx plus any function of y. Okay, similarly, gxy equal to integration of f2 with dy, any function over x. If I start with the numerator, then gxy equal to integration of f1 with dx plus c of y. C is a function of y. Now, in that sense, it becomes y. Now, we have taken force is y cos xi plus sin x, y cos xi plus cos xj. In that sense, f1 is y cos x and f1 is y cos x and f2 is cos x. So gxy dx becomes y sin x plus cy. Now differentiation of this, that is gxy, differentiation of this with y will give f2, any function over x plus any function over x. Now we have now y sin x plus c of y. I'll derive this with y. It becomes sin x plus derivative of function cy. Cy is a function of y. Derivative of cy equal to f2, that is cos x. Now sin x will go that side, cos x minus sin x. Now derivative of any function of y only becomes cos x minus sin x, whereas it should be in y only. There should not be any x at all. Means it is not possible. Getting gxy in generic fashion is not possible. Makes sense? Means when we started, our length vector at di plus dy by dxj into dx, where I'm not calculating dy by dx, let it in y term only. And there we came with the fundamental that d dxy by dx equal to f1 and d dxy by dy equal to f2 to remain in the path independent. This proof is not available in any of the book. Now, if I started with a generic fashion and in generic fashion to be in generic fashion means if I 2 points I can connect through any path. That's why I'm not breaking y and x. In that sense, to satisfy this, our dream d dxy by dx should be f1 and d dxy by dy should be f2. Okay, this dream is not satisfied when f equal to y sin xi plus cos xj, but this dream is satisfied when force field is y sin xi plus sin xj. Here it is satisfied. This proves that through, if I don't break y into x, then this whatever we are bringing into the picture, it is possible only with certain force field. And generic path is possible between 2 points. This concept is possible between 2 points only through certain force field. Through all force field, that is not possible. And this is called path independent force field. Anyway, if you see in the book, the path independent force field starts with the force field dot product d of xi plus yj. That is any breakable from our length vector, that is I plus dy by dxj into dx, or dx by dy I plus j into dy. If you break it, it becomes dxi plus dyj only. D of xi plus yj. Okay, then it is same. Means our length vector works in path independence way or generic pathway. We are bringing new concept of generic path rather than path independence. Means that our energy calculation from one point to another point is same for any path or independent of path, that is the proof right now. For any path, we don't break y into x. For independent of the path, then it goes through the methodology that is present in the book. Anyway, both comes to the same place where it is f vector dot d of xi plus yj, and our is dxi plus dyj, because I plus dy by dxj into dx, length vector breaks into dxi plus dyj only, and that is d of xi plus yj. Okay, I thought of proceeding it into a tangent plane in the 3D. The concept is when we are receiving the end result at gxy. What is gxy? Gxy. So, where that went? Okay, if I consider this as xy plane, then gxy is z. This is the mind-blowing Second thing that I am going to talk in the next session. If this is xy plane, then gxy is z. A function over xy is nothing but the height. Gxy can be considered as z. If f1 dx plus f2 dy brings in an algebraic function called gxy, then gxy function over x and y is nothing but the height, that is z. And that z, we will proceed through z, and we will again show that z is nothing but dz by dx is nothing but f1, and dz by dy is nothing but f2, but other method also. So that we will see. Please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. 91 is the India country code. 9483160610 is the telephone number.